it coming?
Yes, sir.
Yes, sir.
Okay, fine. So let us start with another
Yes,
model
sir.
that is called prototyping model. And the last two models that we have studied is classical waterfall model and then iterative classical waterfall model, and then we have seen that classical waterfall model is very simplistic in nature. So it never assumes that certain kind of error may happen at intermediate at any time. So there is no feedback path which is available from one step to the other step, previous step. So that has been corrected in iterative waterfall model, as we have seen. Now the problem with those waterfall model is that these kind of models are effective when we can understand the whole problem at the very early stage. Okay, this is my actual requirement. The customer as well as the your what is called the developer, both the sides, they become very confident about what type of works need to be done. So in such kind of works, these models may be applicable. But in real life, problems are not that very simple, because something, as I mentioned, something is there in the mind of the customer, and they need to develop something, and they want to transfer this idea from their mind to the developers team or the analytics. So transferring itself is a very difficult thing, because one is what is going on in the customers minds, how they are explaining these things. Because see, you sitting at your place, you may say, "Ki, what's the problem?" Customer may say, "I want this, I want that, I want that, so go ahead and do that thing." See, for simplistic kind of projects it's fine, but when there is a very critical system, complex systems which are there, which never exist, which never exist. So in such kind of big complex systems, it's never really very challenging to take out what is the actual requirement of the customer. Now to cater that, to help that, okay, another kind of very effective model people usually use, or the other company they use, that is called prototyping model. Prototype means is basically toy. Okay, prototype means is basically a toy representation or implementation of a bigger system. It's not that actual system. Try to understand. It's not that actual system, but it's basically a toy representation. So that is a kind of a dummy representation of the any some of the real thing. Okay, that is called prototype. Say someone is going to develop a new car. The company wants to create a new car, or say one flight manufacturing company like Boeing. They may design a new aircraft. So then they never go directly by actual these things. What they do basically, they design it, and then they create a kind of a prototype that actually is not going to you are not, either you are not able to drive that car, or you may not able to fly that aircraft. But that is somewhat look like how, I mean, it will going to be at the final stage. So such kind of problem is also available in the software engineering side also. Now, most importantly, the projects or the that involve graphical user interface. Okay, graphical user interface. So what they do, companies, what they do, they interact with the customer, and then they said, "See, this is my file that need to be uploaded. This is the data I have to enter. This is the thing that I have to scan, and after that, it will going to give me this result." Now, after telling everything verbally, what the developers they do, they create a dummy, a toy implementation of whatever it's there in the mind of these things. But these are purely dummy minded. It will not going to work in true sense. Okay, but only thing is that if you give, say, some text box you have given, you drop down, you have given a name of what it should be there. So if someone can click, it will not going to work. or even if it is work also, no value, no actual competition will going to happen. So it will going to give a feel to the customer ki how the actual software will going to be look like. Now what's the benefit? So user may looking into that or playing with that toy implementation, user may refine its own requirement, and then they can ask, no, this is not the thing that I have looked for. Can you just add here one more thing to do this thing, or can it able to facilitate this particular feature? So then lot of changes again, they start, the developer will take that feedback, and then again they will go on improving that user prototype or that user script. Okay, but if you give some data and all, it will not going to be able to calculate. So that is the way how that prototype grows. Okay, how prototype goes. So that is the thing. It creates a kind of a toy implementation. Okay, but either zero functionalities or very limited functionalities. He say you have given some person's name, say these things. It will going to give a message. See, your salary is ready. But in true sense, there is no salary which is already ready. But just to show to the user how the output will going to be, if I assume if it is working correctly, it will going to say, Mr. This, your salary is already ready. You can download from this button. So that simply it will going to give a message. But actually you are not able to calculate any salary. Neither it will able to, you can able to download. Even if you download also, that file may be preloaded already, so that user can get an effect. If I'm clicking, it's coming down to my drive. So that means, but actually it's not calculating, but it's giving a kind of a I mean dummy demonstration, you can say, that how actual system will going to be look like. So that's why if there is any feedback users give it, they put it over there and then it goes on. Okay, so you cannot rely into that particular system because it's not fully functional. Okay, it's not fully functional. It's either no functionality or having very limited functionality. Okay, and of course it's inefficient in performance because you have never thought of. Only idea is to just make a dummy toy representation of the problem. Okay, now how it actually happens, they go with that initial prototype. First they take out the customer requirement. Okay, and then based on that the developers, they create a prototype from that, and then after that they test prototype by the customers, and then playing with that prototype, customer can give out some what is called feedback, and again it will go and improve that prototype, and again the customer will test that prototype, and it will go on. It will go on until and unless customer is satisfied. Okay, customer is satisfied. Okay, fine, this is done. Now what actually happens? Okay, through this process, customer is going to familiar with what type of input they have to enter, what type of file they are going to upload, what type of report. Okay, report it can generate. So many things, or what are the way that that user interface that will be going to be there. So everything they will going to get a feel idea of that actual system. Okay. So they basically say how much time a hardware controller may take, or how much time, what is called that, if someone is applying some kind of searching kind of thing or sorting kind of thing, so how much efficient these things. Okay, so these things actually you will not going to get a feel from there. Okay, so these issues are always going to be there associated with the prototype, because prototype will not going to give you the actual time and all, because they are not fully implemented. Okay, so why people go for the prototype design? Because for complex problem, it's not possible to come up with a perfectly okay software. Okay, so that's why if you go on doing incremental way or iterative way the development with a model, because say let us assume you have collected the requirement from the user and you have started developing full development. complete development with full functionality of development, and then you have given back to the customer. Then customer may say, no, this is not the thing that I have looked for. Okay, then they have to, the whole work will going to be wasted. Okay, so then they have to do the rework of the whole thing. Okay, so in that case, what happened? They'll lose the whole manpower cost, the time and everything. So it's a huge loss for the company side. So better, instead of doing that, then better working on the full-fledged software. They develop a toy, okay, and give it to the customer, and then accordingly give customer feedback. Then they'll upgrade. Now you may say, what will happen to the prototype? Now, usually what happens? Usually, whatever prototype people do that thing, they normally throw out. Okay, the developer side, they throw that thing. Okay, they don't directly use that particular prototype. But then what is the use? The knowledge that has been gathered, from the customer, and the idea. That idea now they go in fresh like a normal development. Okay, normal development, and then they go for the actual implementation. So in that case, what happened? Once you have a very clear idea about that problem, because the customer also now it's customer is now also familiar with the whole system. At the same time, the developer also, from developer side also, they are satisfied with the problem. This is the thing that customer wants. Now, since it is very clear now that what the problem or software they need to be developed, then in that case, what can do? They can go for the, say, iterative waterfall model. Okay, so that means prototype is the initial stage, and then they go for the traditional software development models like iterative model. So the same thing, they start with that approximate requirements of that, then go for the very quick design for the prototype, and okay, and then once the prototype model is finalized, okay, so that they throw out these things, and then they go for the actual implementation through some of the models as per their choice. Okay, so that is the thing that it has been mentioned over there. Okay, now here what happens basically, multiple times developers need to go to the customers to gather the requirement, because the fact is that requirement is not in a single shop. In the simplistic software development, the requirement may be one time, maybe through some multiple meetings around, but it is one time activity. After completing the requirement analysis only, they may go to the other step. But here what happens, since they are starting with this very small problem to understand the customer's mind, okay, and then they again go to the customer, see, tell me what is your next requirement. Then they again develop that, upgrade the prototype. Then again they go approach customer, see, this is the prototype that we have developed. Now tell me what else to do over there. Then again. So it's basically a kind of a redundant thing, repetitive task of requirement analysis, which was not there in the previous model. Okay, which was not there in the previous model. Fine. So so in that case, as I have mentioned, that whatever the code and design has been done in the during prototype development, they just thrown away, because they are basically just to dummy implementation or toy implementation of that. It cannot be used directly. You need to do it from the fresh. Okay, but only thing is that experience which has been gathered through that process, okay, that the developers will going to utilize to go for the true actual implementation of the product. Okay? So even though the prototype involves some cost, naturally involves some cost, but as a whole, the cost is not that high. I mean, why so? Because you see, these are some of the questions maybe asked. Like, the prototype models is taking extra time, extra cost, but overall cost is low. Why it is so? Because the system development, the prototype development, they incur cost, but not that since it's a basically a dummy kind of thing, because it's a toy implementation. It doesn't require the serious coding, implementation, design, and all full-fledged design. Now, so once, because what, since it's a very quick kind of development, very quick development, very quick design, so in that case, what happens? The cost is not so high. But think about that thing scenario. Like people, the developer develop the whole system. Then with that whole developed system, they give it to the customer, try to get the feedback. Then customer will say, no, no, this is not our requirement. Our requirement is something else. Then again, they have to take back. They have to redo the whole thing, okay, and again they'll have to do. So it is much more higher cost than this particular process of prototype development, okay, because both the sides having a very less idea about the true requirement of the software in the form of a software, okay, and lot of technical issues may arise, because it may happen when customer giving a feedback with the initially developed product or software, they are required to incorporate that new uh, feedback. You may have to completely thrown out. You may have to throw out the entire software and you have to rebuild. Okay, so it is wastage of money in terms of salary or manpower cost. It's about wastage of your time. So a lot of things that may arise if you go in the whole process development and then go for the feedback collection. Okay, so but if you do in that way, that easy, it is very easy to incorporate any kind of change, okay, in prototype, which is not if you have to do it in the full-fledged software development, then the redesigning cost is going to be very massive, huge. Okay, so then it will going to be a loss business for the company. Now another next is evolutionary model. This is somewhat your prototyping model, but the idea here is that the evolutionary model is that this is also repetitive process. This is also repetitive process. But what they do, instead of developing the whole system at the same time, they start developing module. Okay, they identify that this is the starting module or subset sub problem that they will first design and develop full-fledged development. Here is the full-fledged development. They need to first, they have to break down the whole problem into some sub problems. We normally call it as a modules. Okay, and then what they do, say in that picture what you see, that V1 is basically a small part of that software, and then what they do, they give it to the customer. If customer satisfied with that particular sub part, then they add on, increase with the, or go for the next functionality development and adding with that, and then again go to that approach that that is, they have initially it was V1, okay, and then they now having another set they have updated, that is called V2. Now they have joined, integrate these two modules together, and then after that V3, then after the V4, V5, depends on how many modules they have developed. So they just go on developing incrementally. That is called evolutionary. Their evolution means growing generation after generation. So that evolution, what happens? The first small subtask, then again a new subtask they do it, and then they what is called they add it up with the existing model, and it will go on. Okay, it will go on, and then finally once all the modules developed and integrated, then they normally give it to the customer back. Okay, so it's such kind of problems. That's why object oriented problem modeling, object oriented software development is much more fit into this, because in object oriented problem object-oriented modeling, software modeling, or implementation, it's having an inbuilt feature of modularity. Okay, modular development. Okay, that's why object-oriented programming is much more fits into such kind of development. Okay, so as I mentioned, see that it initially creates a core problem, then take the new problem and go on successive way, iterative way. It go on increasing the developing the whole system one after another. In fact, any you take any problem in the real software world, they basically do it such kind of thing. It's not necessary just simple software development. Even in the hardware industry also, they also go like that. They basically what it calls. They basically come up with the initial idea first version, and then they improve by adding some more features to the second version, third version, fourth version. Even in so in the your your what is called non-customized software, which we already have talked. Okay, non-customized software. They are also they are coming up with the first version, then second version, third version, fourth version. What the first, second, third versions? The first versions may having some issues, errors, so they correct it. Okay, in the first version, then they come up with another version, and then they may add some more features, additional features into that, and then again the second version will come, and then third version, fourth version, it may go on. So that is the way how most of the softwares are upgrading themselves based on the feedback, based on the error issues which may crop up during the use of that, and then or they may add features to make it more attractive. So that is the thing. Like if whatever existing functionalities are there in the sub module or core module, they normally upgrade it with the current release, and they basically enhance. You see this if you purchase MS Office or sorry MS Microsoft Windows 10 or something like that. It really creates a lot of problem about the updates, because if you use genuine Windows operating system, it's so irritating that every now and then they go on updating their system files or some other patches, whatever it is there, and then they're going on installing, and it's so irritating that since it's happening in the background, if you don't stop, even if you stop also, that is also not good. But if you don't stop also, it will going to slow down your whole machine. So I'm really fed up of this Microsoft updations and all. It's really irritating. But you cannot stop always. You have to keep it, because sometimes it may malfunction if you don't upgrade your firmware or the system softwares. But anyway, so these updations, there is a regular process, and that is way how evolved the new form of that software actually evolved, and this is what we call it as the evolutionary approach to develop that software. Okay, so what are the advantages of the evolutionary model? Um, uh, like prototype, like prototype, but prototype is a dummy, but it is an actual system, but it's a smaller form, so short form of that. It's not the whole form. So what happens basically? Very even much larger problem than what the prototype model can develop. That you have to go by your evolutionary approach on. Okay, prototype models where it is applicable when the systems are very complex in nature, whether when it is very difficult to take out the user's requirement at very fast shot. So in that case, this what is called your the prototype model is what we find. But evolutionary model is mainly for, it may be easy understandable problem, but if it is a very large problem, then you cannot go for single short approach to develop that thing. It should be very incremental in nature. It should be evolutionary in nature. Okay. So what happens? User may get to work with some part, okay, partially developed system, Okay, and then through that also they can get the feedback. User also get an idea in how my system will going to be look like before the completion of the whole software development. Okay, and in the while using like the prototype, then you can start gathering your requirement. Okay, gathering requirement. So the fully system they can get a I mean actual requirement of the user when you give it to the user part by part incremental versions of the software to the customer. Okay, um, and then what happens basically, since you are trying not the whole problem but trying with a small part of the problem, overall software or problem, then it is quite easy to test and get it correct at the very early stage, because finding an error in a very large system and finding an error in a very smaller system is much easier. Okay, it is much easier. It's a normal thing. Finding I mean, uh, say you have a kind of a rice, okay, a collection of rice, and you have a particular stone chip which is there inside that rice. So it's very difficult to find out if you have a 25 kilo bag. So let us say there is only one stone chip which is there, very small, look like a rice. Now, if you go for the whole bag searching, it's really difficult to do it. But if someone gives you a small katura of rice, it is much easier because the problem searching space is small. So then it is very easy to find out that. Okay, it is very it is very find out to do that thing. Okay, so that's why you if the user having some feedback and all, if it is a smaller system, then naturally that will going to be very easy for the I mean developers to understand what is exact user requirement. Okay, so the core models get tested thoroughly because it's a smaller part, and then you develop incrementally the next part. Okay, and next part, and then what happens basically that reduce the chances of error in the final product, because you are going on adding after every time you are developing or increasing the size of the software, and you are testing and you are integrating, so chances of existence of error at the final stage is normally very less. Okay? So that is the beauty or advantage of this thing. But what is the disadvantage of the evolutionary model? Okay, because it's that is the challenge. Like how are you going to divide that whole problem? Okay, that is the major thing that evolutionary models suffers, because that needs a real creativity. The matter of credit, how you going to chop or cut or making into pieces the problem into sub problems. Okay, if your sub problem design is not good, possibly that also create a lot of problem. Okay, so that's why experienced people, they normally get an idea okay, how which should be the core part, which should be the next part that we can go develop and then integrate. So that way they have to do it. But that is the one of the advantage. If you can do it nicely, your evolutionary model is going to work fine. Okay. So as I mentioned, that if the problem size is very large, that you can apply evolutionary. But it's not good for a small problem where you do not have any scope for subdividing the problem into some sub problems or modules. Okay, so that is the disadvantage which is there in the evolutionary model. Okay, now some more variations of evolutionary model is iteration. Okay, basically what they do, there are some companies, they do the combinations of iterative and incremental development. Okay, whenever they develop new versions, they put in new functionalities. Okay, and then the exact it fits with the exactly with the Microsoft Windows kind of development, where what they do, they may add in the next versions, they may add new functionalities, and then they fix it. Even nowadays the apps, okay, even now the apps now and then they are updating. Okay, they are saying updates is ready. If you don't install, your app will not going to work. Now, if you go to the updation page, possibly you're going to see below, possibly you're going to see below that um, that new bugs fixed, new bugs has been fixed, or new features has been added over there. So that is what actually the iterative and incremental development actually works. So am I audible?
Yes, sir.
Okay.
Yes,
So
sir.
next, what is that? Some more advantages that training of the customers will going to start very early stage because they start using partially developed system at the very earlier stage. So then training happens means customers still definitely wherever you develop a software you need to give a training, take how they use that. So now if you go on instead of giving the whole system, very big system at the same time, possibly it would may be difficult for the customers to learn how the software works. But if you go on giving small part one after another incrementally, then it is very easy for the customer to understand how my software will going to work. Okay, and accordingly by using that thing, getting the customer's feedback is also easier because they are working with a small part, not with the whole system. Okay, and then if I go for commercial softwares, okay, like app and all. By that time, what happens? You develop a very initial form of the software, and then you can give it started marketing on that particular product. Okay, and uh, then you can do it. You see, this is the thing that we have developed. This is the thing we have developed, and these are the features we're going to add it in the near future. Okay, and what happens like since it is being frequently going to be used, okay, and then the releases, whatever releases it's coming up in the market time to time, the updates, it go on fixing the problem. Nowadays what is called um, nowadays you have a automatic logging and feedback system. So if some system performs some errors while running, it automatically reports this to the development team. Okay, see, this is the log. That means these are the things that actually happen because log means all the activities which is going on while running a software. So that log, it will automatic from looking into the log, developers can understand what's the reason of some crashing of the software and all, and then start developing or fixing that problem immediately. Okay, so that actually basically, if you go on doing this releases, then definitely it is easier to fix that. More nowadays, you will not going to find any software which develop one time and there will be no fixing of error or updations of it. Updation is very important in terms of software. But you think about the hardware now. You people develop that hardware, say computer, but they never give a chance to correct that thing if there is really some having some flaw. Because the once they give it, deliver it, there is no chance to upgrade it. Yes, some repairing may happen, but company will going to not going to take any responsibility. That's why they give it 1 year warranty and all. And if really there is some major issues which are there in the hardware, they you may give feedback that is okay, but they can come up to the next launching next product. But you will is going to suffer. But in case of software, what happens? If there is any error in the first version, you will going to get that fixed in the next version also. Okay, so you don't have to worry about that. You will going to get always an updated problem I mean fixed already corrected I mean version during that during the next release. Now this is, let's see another model, and that is the last model that we're going to study. That is called spiral model. The spiral model is a bit difficult, a bit complex, and the fact is that it almost covers whatever model you have studied. Whatever model you have studied, it's having all the benefits. All the benefits is basically incorporated in this particular model. Now, before going to that, let me tell you that in 1988, see, long back, okay, 1988, OM, who proposed that particular model, okay. This is more revised, reformed model, whatever we have discussed, and a bit complex also. So it's like a spiral, 3D spiral. I don't know whether I have a picture. No, I do not have any picture. Think about the tornado. You know that tornado कैसे ऊपर चढ़ता है, round going up. So think about this spiral. This is a kind of a spiral. From button to, if I can show you a 3D picture of a spiral, it look like that. Okay, loop, but smaller to the larger. Okay, if I show you the these things. So each loop, okay, each loop is basically each loop basically what phases of the software process. Okay, so phases means the versions. Okay, the versions of that phases. It's somewhat like your evolutionary approach. Okay, it's somewhat like your evolutionary approach, and then it will go on develop these things. So the innermost loop, maybe the system feasibility. The next loop will going to be the system requirement and definitions, and the next one with the system design and so on. Okay. So this way, I mean, every loop actually corresponds to certain phases of the software development. Okay. And then what happened? There are no fixed phases in this model. So there are no fixed phases into that model. I'll show you some example. I'll show some example. So let us see these things. What is actually happening? There are normally the spirals. Spirals are basically divided into 4 quadrants. Okay, the 4 quadrants. I don't know what exactly that. This is more refined way that they normally do it. You will get a flavor of almost all the models over here. The major models, prototyping models, evolutionary models, iterative evolutionary models, everything you will get. But very simple idea that I'm showing you. Let us say you are going to develop a software A, okay, and then you have modules. It's not models, modules. Okay, PQR are basically the modules. Now what they do? They go by the full phase. Okay, the full phase of that particular development. So the module or the subpart, say P. Okay, P will go by the requirement analysis. P will go by the design, coding, and testing. All the phases it will pass through that particular submodule. Then once it is done, once it is satisfied, then they go for the next submodule, Q. Okay, then Q will go by the requirement analysis, Q will go by the design, coding, and testing, and then they add it with the previously added incremental way, evolutionary way. They add it up with the previous model, and this way, if there are 4 parts or 4 versions, sorry, 4 modules, you can segregate out. Then the PQR will go by all the 3 phases, and then finally we will going to get the product A. And wrongly mentioned what is called PQ. Actually, this is it should be yeah, no, Q may be the final one. Q may be the final one. So Q is the latest result. Q is the final one. So that is consisting of module P, Q, and PQ. Actually, I have written something I think wrong in that. P, Q, Okay, okay, fine. So the incremental way, what will happen that let us assume the P part is the most core part. Then you have developed testing after testing and all TP. Then RQ. RQ means the requirement for module Q. RP means the requirement analysis for module P. TR means design of module R. The DQ means design of module Q. Then similarly, that for coding also, testing also. Like what? Since it's an incremental, so what is happened? That P, after that P, you're going to add TQ. Okay, then another next module, and then you add it up. Then it will going to be TQ. Okay, it's not TP. It's once you are adding TQ. I mean TQ means the Q module. Once it is developed, okay, you now it's going to be incremental. That P and Q together it will going to be Q. Then no existence of P. Okay, no existence of P. So TP TQ it will going to be TP Q, and then after that if you develop R, then it will going to be TQ plus R. Okay, TQ plus R, it means no more existence of P. Now it's you have in your hand TQ. So TQ you are adding TR. Now it will going to be the next version set TR. Okay, so TR, and then no existence of TP and sorry, or P or Q. TQ means is the testing of P and Q. So P and Q. So the Q module and Q module no more is existence. It will be there inside, but no, you cannot segregate out. So now it will going to be the R that will going to come from there. Okay. So in this approach, what happens in spiral model? The development team they just first decide how to structure the project. Okay, into different phases. Okay, that is somewhat like a revolutionary approach in terms of doing this. They cover the phases. Okay, and then they work with the traditional approaches. Okay, they work with the traditional approaches, and then they go on adding some extra phases over there if necessary. If this is my phase, P Q R S T something like that, that you can go ahead with that. Okay, so for specific projects, that basically varies. Okay, so in the each loop in the spiral is the is divided into four quadrants. Okay, so I'll show you another elaborated picture. See this particular picture. What are those these things? The quadrants. This picture is just for example, but in true sense, these are the different quadrants. Objective determination and identify alternative solutions, identify and resolve risks, develop next version of the product, and then review and plan for the next phase. So these are the four quadrants that it may pass through. Okay, pass through. Say the first task is your basically requirement analysis. Then requirement analysis will going to pass through all the phases. Say object determination and identify the alternative solutions for that, identify and resolve the risk. Okay, here this is something new which has been introduced, that is called risk analysis. Okay, we'll study in details later on in the later stage of the course. Risk analysis has been introduced in that model, which no of the models, not of the models basically. Just a minute. Am I audible?
Yes, sir.
Am I audible? Yeah. So these are the four quadrants: that object determination, identify, and alternative solutions. Now, every phase are equally important. Okay, every phase in the software development is equally. Say, what are the phases? Phases means say software analysis, design, coding, testing. So every phase is equally important. Okay, and every phase need due attention. What they have done, they have divided into some what I say, activities for every phase. Say analysis. Requirement of the analysis, we have to see your objective. What we will do? Okay, how we going to do it? Okay, whether we go with the customer. Okay, and then identify solution if there is any issue. What we can say interview is not possible. Say they may not able to go over there. So what will be the alternative solutions for them? Similarly for the design, similarly for the coding, similarly for the testing. Now the next what can happen? Identify the risk. So identify the risk. So risk means at the very early stage they assume somewhere. If it goes wrong, okay, if it goes wrong, what is the possible consequences? Okay, what is the possible risk that may incur if it fails? If such a solution may fails, okay, there are so many alternative solutions. So if it may fails, okay. Now they basically try to identify those risks which are involved. No other model talk about risk factors which may involve, which is very dangerous, because a software you may encounter this problem at very later stage, and that is going to be a very I mean havoc. It may create a problem in the whole development pipeline, because risk has been identified or the problem has been identified very later stage. So if you can go very carefully by every time you are analyzing the risk factor, and if the risk identified, okay, how to solve that problem? Do we need to again go for another solutions? Do we need to do that, perform an activity in another form? So everything can be done in case of risk analysis. And then what they do, uh, they go for the actual development. Okay, actual development, they go for the actual development of the sound, that part. Okay, and then review, means give it to the customer to get the feedback and all. Okay, and then it goes for the next phase of development. Now after going through that, see, look at that bigger picture. Okay, you see that your spiral starts in the very lower level. That it starts with that determining the objective alternative solutions and all. It starts with that say requirement analysis. Okay, requirement plan life cycle. That's एकदम smaller one. So that is the starting. Okay, and then they go for the development plan and then integration and these things. So these are basically the course. Okay, the round things. Every circles is basically the phases of the software. You can see from here. I don't know the mouse you can see or not. Okay, this one. These are the different phases. These rounds. Every rounds is basically with somewhat. This is somewhat. If you see the 3D picture, it's somewhat like this. These are the spiders. This part, say this is requirement analysis. This part, say this is basically design development plan. Then this is integrations. Okay, then go for the next phase. So the fact is that here you see, you can see first you see here, this is continue. This is continue. Go for the next step. This is continue. Means once you complete the whole round, okay, once you complete the whole round, possibly you are coming up developing with a fast module in one. Then the same process you may do it for the module 2. You may do it for the module 3. Okay, so every loop. So that means it's very the spiral is growing. Okay, the spiral is growing, and for every module you can do more serious attention on that. Say for module 1 you are doing requirement analysis, life cycle plan, you started these things, then it goes to the risk analysis. Okay, risk analysis, risk analysis. Okay, and then for that module you can develop a prototype. Then then you can go for the simulations. Okay, simulations. And then what is basically then the simulations. After doing that thing, what will happen? It will go for the again the development plan. Development plan. And then the next plan, what will going to be there, the next phase of that. So and then again it goes to the risk analysis. Okay, and then again you create the next prototype. Okay, and again you can go for the simulations and all, and then it will continue. Okay, see every time everything whatever you are doing for that. I'm talking about only one. This whole spiral is say about one module. So then go on. Iterative process prototype will go to get it. Then once the prototype is done, after doing that, then it's basically an operational prototype. It's almost close to the actual software or implementation of the module 1. Okay, and then you can test these things, benchmarking. Then you can actually go for the actual detail design. Okay, then coding, testing, everything you can do it for this module 1. Okay, and then after once it is done, then you can go for the next module 2. Okay, module 2, and it will go on doing this thing. So that way you now M1 is a module, then now you're going to integrate M2, and then finally you can integrate say M3. So that means you're going to get the flavor of almost all the models, whatever we have studied, you will get it from there. You see that this is somewhere it's a waterfall model, or you can say it's an iterative waterfall model. You can apply over there from there. Here it's a prototype development. Okay, and this overall thing, this one is basically modular approach or evolutionary approach. So all the models whatever we have discussed, you're going to get a flavor into that model. It's very detailed. You cannot think of anything beyond that. Everything has been taken care in that model. At the same time, it incorporated or introduced this new thing that is called risk analysis. Okay, the risk analysis, and in that way, basically, you are coming up with a less error prone or less error software. Okay, less erroneous software. I must say less erroneous software. So identify this. Whatever I have discussed, again I am repeating. What the first quadrant says is basically identifying the objective of the phase. Okay, so then it analyzes the risk. Okay, objective, and what is that risk? That's what we mean by risk. Risk means any adverse circumstance that might hamper the successful completion of a software project. That is called risk. So that means some guessing, some idea, some experience only, because you're going to see really it's going to be created danger or not. But where the role of an experienced developer or analytics or manager is necessary over there, they based on their experience, they can assess the possible issues, risk may occur if I go on developing the same thing incremental way. So there may be chance that it may occur some kind of risky factor at the later stage of the software. So then if you can detect the early stage, so then you can find out some alternative solutions for that at the very early stage. Okay, if there is any issues may crop up over there. So in the second quadrant, what it is happening for each identified project risk, that they were, the experts they identify. They do a thorough analysis, okay, thorough analysis to be performed, okay, and then all the necessary steps to be taken up to mitigate that risk, okay, as far as possible. You cannot give a guarantee to that, but as far as possible, the risks which are involved over there, that can be, uh, handled, taken up at the very early stage over there. So exactly, nothing coming into my mind. Some example that I can tell you what the risk can happen. But if it comes to my mind, naturally I'm going to discuss this thing later on. Mm. I can give you some small example that say banking sector. So initially you have developed some small thing. Okay, you have done some analysis and all. And mind it, this is applicable to all the phases of that software development. Requirement analysis, design, testing, coding, everything. Okay, every time it's not only for the whole software and their risk. Okay. So, but what happens, say, the banking systems, if you go on with finding these things, you can identify if they go by these kind of less security issues, then possibly they may create a great difficulty of loss of money for the customer or for the bank. So let us incorporate more features, security features at the early stage. So in that way, you can actually avoid certain level of risks associated with that software. Or more specifically, the development related issues or implementation related issues. If you can handle at the early stage, possibly that may come up with a less erroneous software. Okay. For example, if there is a risk that the requirement is inappropriate, it may give an effect to the design, it may affect to the coding, it may affect in the finally delivered product. And all. So if you can identify any issues, errors, at the requirement stage itself, error of the requirement, error in the requirement, if you can identify there itself, then basically you have half done with all the problems. You are basically cutting down all your problems to grow at the later stage. Okay, so risk analysis is very important phase to have a very effective implementation of the software. And of course, the prototype as I've shown that can be developed to get a better idea what customer wants. Then the development and validations that is in the third quadrant. You can see the third. It develop and validate the next level product. How it will be the next level product will going to be, because after that you are going to get the prototype and then you can play with the prototype, see how the user wants. The user will to play what is called user will to play with the prototype, and then they incorporate all the feedbacks from the customer. And then the fourth one is the review and planning. Okay, what is that review? Review the results of the user, user use of that with the prototype. Okay, and then they can go for the next planning. Okay, fine. These are the things that need to be added. These are the things that need to be removed. So everything that incorporate. And this is the way how they plan. What should be the next step to be taken up. Okay, so each iterations around the spirals, whatever it is there, okay, it will grow, and then basically ultimately once it is done in the higher side, in the bigger circle, your actual product will going to be available at the end. Okay, so from smaller to the larger, the spirals like a tornado. As I've shown, the tornado, they grow up and then they settle down to get the software. So as I mentioned, it's basically called meta model. Why meta model? Meta model means it's model of all the models. Okay, so models of all the models, because these models actually incorporate encompass all the type of models that we have discussed. So a single loop of spiral represents a waterfall model. Okay, because it's having all the phases. So it uses evolutionary approach, as I have mentioned. Okay, single round One single round means one module development. So that means it's an evolutionary approach also. Okay. Then it's also prototype, as we have discussed. Here also you can develop a prototype to get the user feedback through risk analysis. You can reduce the probability of error in the software, final software. Okay, and remaining is, as you know, that waterfall model I've shown you in the picture how once it is done, once it is finalized a particular phase, and then they can go for the prototype development. Sorry, the waterfall model for completion of the prototype. Now let's see some kind of comparison. The iterative waterfall model, it's very commonly used, or obvious from the small problem, well understood problem, because if it is already known, okay, I know what to develop. So such kind of problem can be developed through iterative waterfall model. Okay. Prototype model is what? If it is very complex in nature, difficult to understand, then to get the idea clear, you can go for prototype development, refining process, okay, to get the actual user requirement and to solve any technical issues which may be there over there in the. Now, evolutionary model is suitable for large problems, as I mentioned. Okay, so only when you then have you are able to decompose the models in incremental way. Okay. Good thing is that evolutionary model you are developing small part and you can go on delivering these things. And in this way, what will happen? You will going to get a payment, partial payment also. So you go on developing models, add it with these things. So nowadays, almost all are basically evolutionary approach they are taking. They normally divide it into any problems can be divided into some modules. See for our examination. What did so the whole problem is the whole examination system with segregate into different parts, like say mark entry system, say student registration system, say access grade evaluation system, say internal marks registration system, final marks registration system, certificate generation system. So almost all the tasks are can be divided into modules. Then what happens? Developers team will go on developing each and every modules and go on delivering these things to the university. Okay, examination department, and the examination department immediately start using that thing. They start playing to that actual implementation of the subset of that whole software, and then if they have a this thing's feedback, they can give it to the developer. They can now learn. How to use that software, and then later on development was born. So partially they pay that thing to the company, and then the company continue the next development, and then once ready they deliver and then get the next. So that way nothing is stopped. Delivery also not stopped. The user also go on using that product. At the same time, the developer team also getting the money time to time after releasing the versions or what is called modules. Spiral module is suitable for very difficult problems, software problems, and that involves several kind of risks over there. Say someone is developing a kind of a software for a aircraft. Okay, so for a software they can develop for what is called for missile launch. So they are very risky kind of activity. I'm giving you some small example. Risky kind of a software, because if it malfunction, okay, say in the flight, autopilot, okay, if it's somewhere malfunction, if some if in the mid air, in the mid sky, if it not working properly, you can understand. You can understand what will be the risk which may be there involved over there. Okay, if it is a or a missile, you know that I think I have mentioned one day. If the missile due to the malfunction of the software, missile has gone to Pakistan. Okay, and there will be some very something very above may happen if such kind of things occurs anywhere. So that's why risk analysis is very important. Is such kind of software development. Okay, such kind of software is very important for me. So spiral model actually take care about all those things because it's inbuilt with that risk analysis. So with that, today I'd like to end up these things because we have completed our spiral waterfall model. Now let's see what we're going to study in the next class. I think we're going to study in details all the phases now. But anyway, I think the last week of this month, which date? Last week, something. I think I can take one example on examination on May, 31st of May. Will it be okay for you? Okay, sorry. Okay. Because now what will happen? May, June, July, all the 3 months. By these 3 months, we'll have to finish all the three sessions. Okay, by the three sessions. So we'll take that. So at the last week, tentatively 31. It may prepone. So get ready for that also. I will prepone that thing. Preferably 31st. It may prepone to the previous week also. So I'm going to take one exam and let's see. I may give two exam related sessional and one maybe assignment kind of sessional. Let's see. But I have not thought of like that. I may give you some problem and then you have to design that problem. Anyway, so let's see when I can able to take the class because I am away from Sikkim. Not away from Sikkim. I'm in SMIT right now. So hopefully I may go back and then I'll come regularly again. I'm able to take the classes. Okay. So thanks for today. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.